Welcome to our show. Today, we're diving into a fascinating topic that's literally right under our feet. We're going to explore how scientists measure the size of the Earth. Now, that's quite a big task, isn't it?
Absolutely. It's a challenge that has intrigued scientists for centuries. When we think about the Earth, we often compare it to the vastness of the universe, which is about 13.8 billion years old. But even though our planet isn't as enormous as the cosmos, it's still incredibly large from a human perspective.
Wow, I never really thought about it that way. So just how big is the Earth exactly?
Well, we now know that the Earth's circumference is about 40,000 kilometers. It weighs approximately 5,972 quadrillion tons and is over 4.5 billion years old. But here's the thing. For curious young scientists, simply knowing these facts isn't enough. They want to understand how we figured this out in the first place.
That's a great point. I mean, how do you even begin to measure something as huge as the Earth?
It's a fantastic question. Let's start by thinking about how we measure everyday things. When we measure our height, we usually stand against a wall with a large ruler or measuring tape. For smaller objects like pencils, we compare them to a ruler. In both cases, the measuring tool needs to be longer than the object being measured.
Right, that makes sense. But I'm guessing we can't exactly make a ruler bigger than the Earth, can we?
Exactly. That's the fascinating challenge scientists faced. We can't create a ruler bigger than our planet, so they had to develop indirect methods to measure the Earth's size.
Indirect methods. That sounds intriguing. Can you give us an example?
Sure. It's actually similar to how scientists study the Big Bang. They couldn't directly observe this cosmic event, but they found indirect evidence through cosmic microwave background radiation. Similarly, clever scientists had to use creative thinking to uncover the secrets of our world and measure the Earth indirectly.
That's amazing. It really shows how ingenious scientists can be. So what are some of these indirect methods they came up with?
Well, there are two main approaches I'd like to discuss. The first method involves traveling around the Earth. While we can't create a ruler that wraps around the planet, we could theoretically circumnavigate it and keep track of our journey.
Circumnavigate? You mean like travel all the way around the Earth?
Exactly. By recording the time taken and the distance covered each day, we could calculate the Earth's circumference. But here's where it gets tricky. How would we actually go about it?
I guess walking would take forever, right?
You're spot on. Walking would take far too long, possibly decades. Driving might seem faster, but roads don't follow a perfect circle around the Earth, and obstacles like mountains, rivers, and oceans would force detours, leading to inaccurate measurements.
So what's the best way to do it?
The most efficient method would be flying, as planes can travel quickly and in relatively straight lines. In fact, a nonstop flight could circle the Earth in about 15 hours. By multiplying the flight time by the plane's speed, we could estimate the Earth's circumference.
That's brilliant. But wait, didn't scientists figure out the Earth's size long before we had airplanes?
You're absolutely right. Scientists actually determined the Earth's size long before the invention of airplanes. You might wonder if they used hot air balloons, which were invented earlier than planes. Unfortunately, hot air balloons aren't suitable for this task because they're at the mercy of wind currents and can't maintain a consistent direction.
Fascinating. So if they couldn't use planes or balloons, what did they do?
This brings us to the second method, which is quite ingenious. They treated the Earth like a watermelon, imagining it cut into equal slices.
The Earth as a watermelon? Now that's an image I never thought I'd have in my head.
It's a great visual, isn't it? The idea is that if you can measure one slice accurately and know how many slices there are in total, you can calculate the Earth's size. This is the approach that allowed scientists to measure our planet even before the age of flight.
That's incredible. But I have to ask, how exactly did they implement this method? It seems like it would still be quite challenging.
You're absolutely right. It was a significant challenge. The exact implementation involved some complex calculations and observations. Scientists had to make precise measurements of angles and distances on the surface of the Earth, and then use geometry to extrapolate these measurements to the entire globe.
Wow, that's some serious brain power at work. It really makes you appreciate the effort that went into figuring out something we now take for granted.
Absolutely. It's a testament to human ingenuity and perseverance. These scientists faced seemingly impossible problems and came up with creative solutions to solve them.
It certainly is. Now, I'm curious, if you were tasked with measuring the Earth today, what method would you use?
That's a great question. With modern technology, we have even more options available to us. We could use satellite measurements, GPS technology, or even laser ranging. But the principles behind these modern methods are still based on the creative thinking of those early scientists.
It's amazing how those fundamental ideas still apply today. This has been such an enlightening conversation. It really shows how creative thinking can solve seemingly impossible problems in science.
Absolutely. It's a reminder that science is not just about memorizing facts, but about asking questions, thinking creatively, and finding innovative ways to understand our world. Whether we're measuring the Earth or exploring the farthest reaches of the universe, that spirit of curiosity and problem solving is what drives scientific discovery.
Well said. I think we've all learned a lot today about the Earth, scientific methods, and the power of creative thinking. Thank you so much for sharing your knowledge with us.
It's been my pleasure. I hope this discussion has inspired our listeners to look at the world around them with renewed curiosity and appreciation for the scientific process.